My name is Prithvi Sharnath and I'm the TA for this course, Engineering Mechanics. So this is week 9. So we will solve some questions and I suggest that you should try solving the problems along with me. So we'll start. So for the first problem, in a system consisting multiple interconnected rigid bodies, each member may have a separate instantaneous center of zero velocity. So this is true. So in case of multiple interconnected rigid bodies, in case of a system where there is multiple interconnected rigid bodies, each member can have a separate instantaneous center of zero velocity. So the next question, in which of the following cases can rotating frame of reference be used for analysis? So can you tell me which options are correct? So for this, all the four are correct. So in this problem, two discs D1 and D2 are attached together and are confined between two platforms as shown. At the instant depicted, platform A moves to the right with a constant velocity as shown, while platform B remains stationary, such that the discs roll over platform B without slipping. What is the magnitude angular velocity of the disc assembly in radians per second? So can you try solving this problem? Only platform A is moving, platform B is stationary, and the disc rotates without slipping. So you need to find the angular velocity of the disc assembly. Can you try solving this problem? So anyone got the answer? So I will calculate about this point. So can you tell me what should be the radius? What should be the r for this? D equals to omega into r, right? So if I want to, what is this distance? This is R, right? So R is 0.5 plus 0.25, right? So this is equal to 0.75, right? So the velocity is already given. V is 1.5 meter per second. So I need to find the omega, right? Angular velocity. So omega is dA by R. That is 1.5 by 0.75. Which is equal to 2. So is there any doubt regarding this question? You can tell me if you have a doubt. Yes, that's correct. So, moving on to the next problem. For the mechanism shown, link AB is rotating with an angular velocity omega AB equals to 4 radians per second. If the instantaneous center of zero velocity for the link BC is represented by IC, determine the following quantities at the instant shown. So, this is a mechanism shown, and omega AB has, the link AB has omega, which is 4 radians per second, and the instantaneous center of the zero velocity for link BC is represented by IC. So, for this problem, you need to find out the location of IC first. First, you need to locate the IC. So, can you do it? So, can you tell me where is the IC located? Is it inside the quadrilateral or outside, or it lies outside the quadrilateral? Can you tell me that? You just need to draw perpendicular lines from the tail of the arrows and then locate. So can you tell me, is it inside or outside the quadrilateral? So this is the IC, right? I just drew the lines perpendicular. I just extended C. This BC is perpendicular to this link CD, right? And this AB, the velocity VB is perpendicular to AB, right? So I just extended the lines AB and CD. And the point where they meet is the IC, right? So it lies outside the quadrilateral. So the IC lies in region 2. Is there any doubt regarding this? See, because this is perpendicular, this is perpendicular to this line, and this is perpendicular to this line. So what I did is we extended the lines, and the point where they meet is the IC for this link. The IC for the link BC. Is there any doubt regarding this thing? You can tell me if you have a doubt. So are there any doubts? You just can tell me if you have. Okay. So moving on to the next part of the problem, the absolute value of the angle in degrees between the link BC and the x-axis. So you just need to use the geometry to solve this question. Just try solving this. Basically, you need to find this angle. Let this be beta. So just try finding out this angle. So did anyone get the value? Not exactly, it's higher than 30. Okay, we'll try solving this out. Solving this problem. So in the problem, it is already given. This length is 3 meter. This is 4 meter. And this is 5 meter. So this distance is what? 3 sine 45, right? This height. This is 3 sine 45, right? So similarly, I can say this is also 3 sine 45. Now, let us assume that this length is L. Now, what can I write from this? I can write and this angle is 30 degree, right? So this is 60 degree and this is 30 degree, right? This angle. So this part, this length, from this triangle I can write it as L cos 30, right? So L cos 30 is also equal to 3 sine 45. Is that clear? Because they are at both height, both the points are at the same height, right? So L cos 30 equals to 3 sine 45. So from there I can calculate L. 3 sine 45 divided by cos 30 gives L. So L is root 6. Now I know this total length CD is 5, right? So this is nothing, this part is nothing but 5 minus root 6, right? Is there any doubt up till here? Tell me if you have a doubt. Okay. So now I can just use the sine rule to find angle beta. So sine beta, the opposite side is 5 minus root 6 equal to, can you tell me what is this angle? Can anyone tell me what is this angle? No, not 90. 90 is the angle which BC makes with this line CD. This BCD is not 90. Is that clear? Yeah. So this is 60, right? this is 60 degree, right? This angle, this angle is 60. So this is also 60, right? Is that clear? I'm just drawing a parallel line. So this is 60. So I'll just write sine of 60 degree divided by the opposite side, that is 4 meter. So from here you need to calculate beta. So sine beta equals to sine 60 into 5 minus root 6 divided by 4. So beta is sine inverse of sine 60 into 5 minus root 6 divided by 4. So this is 33.52 degree. Is this clear? How I got this angle beta? Okay. So anyone is having any doubt? You can tell me if anyone has doubt.
No, ma'am.
Sorry, you're not audible. You can write it in the text box as well.
No, ma'am. I haven't done that.
Can you write it in the text box? I cannot hear you. Okay. So the next part, the absolute value of the angle between the link BC and the x-axis. So this is the angle. So the next problem, the absolute value of phi is, so you need to find this angle phi. This angle phi you need to find. So can you try finding out phi? So you need to construct so you need to construct triangle. No, you don't need to construct a triangle for this problem. You just see how can you get. You know this angle beta, you know this angles that the angle at E. So let this point be E. And this angle is phi. As per the problem, right? Yeah. So you need to calculate this angle phi. tell me what is phi? You can solve this by using this diagram. Yeah, it's yeah, more than 3 degrees, slightly more than 3 degrees. Yeah. So I know beta, I know this angle at CEB is 60 degrees. So I can calculate the angle ECB, right? So the angle ECB is 180 minus of 60 plus beta, right? And beta we already calculated, which is 33.52. So this becomes 86.48 degree. Now I know this angle. This angle I know. And I know the total angle is 90. This total angle is 90 degree, right? So I can write this as 36, sorry, 86.48 plus 5 equals to 90 degree. So from here phi equals 3.5 degrees. So is there any doubt in this problem? In this part of the problem? Okay. So there is another problem. There's another part to this. The distance of point B from IC. So they are asking for this distance. Can you try this? You can solve the problem using this figure. Can you try solving this? did you get the answer? So, okay, I'll solve this then. So from this figure, can you tell me what let this point be? F. Can you tell me what is this angle AFD? That is this angle. And so in triangle AFD, angle AFD is 180 minus 60 plus 45. This is 75 degree, right? Now, so can you tell me what is this angle? So you need to find this angle, which is 75 from considering this triangle AFD. So you need to first calculate this angle AFD, which is 75 degree. Now can you tell me what is this angle? This angle is 90, right? So this total angle is 90 plus 5, right? This total angle is 90 plus 5. So angle FCB this angle FCB 90 plus 3.52, which is equal to 93.52. Now, I can again use sine rule to find this length FB, right? I know two angles and I know two sides. I know two angles and I know one side, so I can find out the other side, that is FB. So, using sine rule, sine 75 degree, which is opposite to the length BC, that is 4 meter, equal to sine 93.52 divided by length FB. So this is the distance that I need to complete. That is asked in the question. So FB equals to sine of 93.52 into 4 by sine 75 degree. So that is approximately 4.13. Is there any doubt regarding this part of the problem? So, is there any doubt regarding this part of the problem? Okay. So, next you need to find the magnitude of the angular velocity of the length BC. Can you just find out the angular velocity? Very simple. So did you get the answer? So did you get the answer? you can look at this figure. Move on. So did anyone get the answer to this? So first you need to calculate BB, right? BB equals to omega into R. So what is this omega? It's given in the problem question. It's 4 radians per second and R is 3 meter. So this is 4 into 3, 12. Now you need to calculate angular velocity of the link BC. So omega BC is BB by this distance which you calculated, right? So FB. So 12 by 4.13 is nothing but 2.91 radians per second. Is this part of the problem clear to everyone? Okay. So the next part, next problem. At least show the robotic arm OA is rotating in anti-clockwise direction with constant omega 1 equals to 8 radians per second. Simultaneously, the grip AB is rotating. So this is like as anti-clockwise. Yeah. This is anti-clockwise with constant omega. This is anti-clockwise. With constant omega 2 equal to 10 radians per second, both measured relative to fixed reference. Evaluate the following quantities for the object held at grid B. So first you need to calculate the magnitude of absolute velocity of point A. So can you find out the velocity at A? So can you tell me the answer to this? So this is the omega is with respect to the fixed axis, that is x y axis, x or y axis. Yeah, exactly. So dA equals to omega 1 into r. So omega 1 is given as 8 and r is 180 millimeters. So you need to convert that into meter. So 180 into 10 to the power minus 3. So that is 1.44. So this is the answer. Now the next part. The magnitude of the absolute acceleration of point A. You can look at this figure. Now you need to find the absolute acceleration. Can someone confirm if I'm audible? Okay. So can you tell me what is the acceleration? This is nothing but omega square r, right? So omega we already know. So that is, yeah. Now, for an observer rotating with grip AB, the object B will appear to be stationary, to trace a circular path, or to approach the observer, or to trace a non-circular path. So suppose the observer is on the grip. So the observer is rotating with the link AB. So how will this grip object at B will appear? Suppose there is an observer who is rotating. Yeah, exactly. So this will be stationary. Next part, the motion undergone by the grip AB is no, it is a general plane motion. Like if you observe the grip AB, it will undergo general plane motion. So these are the problems that we discussed. So for this problem, these two discs D1 and D2 are attached together. So we are asked to find the magnitude of the angular velocity of the disc assembly. So the platform B is stationary and platform A has velocity towards the right. So from there, from this information, we are asked to find out the angular velocity of the system. So I calculate with respect to this point. So the total distance r would be 0.5, that is this distance. That is this distance plus this distance, which is nothing but 0.5 plus 0.25, and from there I just simply substitute. No, top portion is not neglected. It is said that these two are attached, right? So both of these will have the same angular velocity, right? They are attached together. Yeah. In the question it is mentioned that these two are attached together. So omega is dA by r. So this comes out to be 2. Now in the next part of the problem, there is a mechanism and the link AB is rotating at an angular velocity of 4 radians per second. So for the first part of the problem, you are asked to locate the IC. We simply extended these lines because for finding the IC we need to draw perpendicular line to the tail of the arrow and then extend them, and the point where they meet is the IC, right? So in the problem we can see that the link AB, the velocity BB is perpendicular to the link AB, and BC, velocity BC is perpendicular to the link CD. So we simply extend those lines, and the point where they meet is the IC, and this IC lies outside the area enclosed by the quadrilateral ABC. So is there a doubt in this part of the problem? You can tell me if you have a doubt. Anyone has any doubt up till here? Okay. So next we are asked to find this angle beta. So I simply draw a parallel line and I know the height. I can calculate the height. So this height is 3 sine 45. Similarly, assuming this length CE, so this is E. This point is E. So assuming this length ED to be L, I can write L cos 30 is equal to 3 sine 45, right? Because both are at same height. So from there I can calculate L, which comes out to be root 6. And after that, I just use the sine rule in the triangle CBE. CBE. So sine beta by 5 minus root 6, which is the opposite side to beta, and sine 60, and the opposite side is 4. So from there I get sine beta equal to this expression, and from there I get the angle beta. So is there any doubt regarding this? Okay. So now I got beta. Next part, in the next part we are asked to find the angle phi. So what I do, I find out the angle ECB, I know beta, I know the angle, this CED, 60, which is 60. So I know the angle BCE, BCE or ECB, which is 86.48, and the total angle, that is this angle plus phi, is nothing but 90 degree, right? Is that clear to everyone? Yeah. So from there I get phi. Now they have asked the distance of point B from the IC, that is this distance. Now I consider this triangle AFB, this bigger triangle. So I found out that this angle is 75, and then I considered the triangle FBC. Considering this angle, this triangle, I could easily find out this distance FB. Because FCB is nothing but 90 plus 5, that is 93.52. So simply using the sine rule, so opposite to 75 degree there is this length which is 4 meter, and opposite to this angle FCB is nothing but the length FB which we are asked to find. So we can calculate FB from this sine rule. Is there any question regarding this part? Okay. And now just they have asked the angular velocity, which is nothing but simply you have to calculate it using the formula. You got the length of FB and you know the VB, angular, this VB, which is nothing but omega into R. Omega is given as 4 radians per second, I guess. 4 radians per second. And this length is 3 meters. So VB we know, and we also calculated FB, which gives the angular velocity of the link. Now in the last problem, both of these links are rotating. OA is rotating with constant omega 1, 8 radians per second, and the grip AB is rotating with omega 2, 10 radians per second. So you are asked to find out BA, which is nothing but omega 1 into R, and the acceleration, which is omega square into R. So, is there any doubt up till here? Okay. And this was pretty simple. For an observer rotating with the grip AB, the object will appear to be stationary. So are there any doubts regarding today's problems that we solved today? Okay. Then we can stop here.